you probably can't see my screen now. So let me know if you can see my screen. Just I'll need a signal. Let me know if you can see my screen. Can you see my screen? Oh, cool. Adesua, yeah, thank you, Sandra. Nice. Oh, that makes sense. Awesome. So I think I can go straight into it. Yeah, so pretty much about me. My name is Yomi, and have I've been a software engineer for I've lost count, but I probably like just cap it at 12 years. I think I've been a software engineer since 2008. That's when I started, anything code stuff, right? I don't know if some of us are able to probably remember the days of what's it called? Basically the days of Edge as a network provider, not as a network provider, but the internet strength then was Edge, and we used to make use of when you basically would download Java applications, on your or probably like Symbian phones, that was when I started software engineering, sort of. So it's quite a while. Damola, yeah, I can see you come from way back, right? I can imagine. Yeah, so I've been a software engineer for quite a while now, and yeah, I currently work with Shopwire DK as a software engineer, where I basically like develop apps for customers and every other thing. But before we proceed, I'd like to have an idea as to my audience, so that would help me shape how I'm having this conversation. So, what's your current skill level? High, low? I'm talking about as a software engineer. What skills do you probably have? If you don't have any skill in software engineering, you can probably like drop it in the chat that no skill, zero knowledge. If you have any skill, maybe you can do HTML, you can do CSS, you can do JavaScript, you can do Java. Low skill, Sandra. What skill can you do, Sandra? I'd like to know. No knowledge, Uche, that's fine. Oh, nice, you're learning Python. Okay, Node.js, Kinley. That means you've gone quite far. That's nice. Samsung SMAO. Well, your name is not there, but no skills, zero skills. Okay, I'd like to get more feedback before I proceed. Um, okay, I'd like to say zero skill. Okay. All right. That makes sense. I sort of understand that. And please let me know if you still can see my screen anyway. So that's Java. Oh, Damola, that means you're quite good. Okay. Low skill, you're familiar with HTML, CSS, a little bit of JavaScript. Okay, cool. Yeah, so this session isn't going to be so focused on Elixir. Wow, you must be a boss, Hassan Idris. I probably will have to come and learn some Elixir from you, maybe. All right, so let me just go straight into it. So, first, I want to have this disclaimer that software engineering isn't just all about coding. That's the first thing I want to clear. Yes, you're probably here because you maybe want to test my coding skill. Well, I'm sorry to disappoint you. I'm not going to write so much code, and there's a reason. You being a software engineer is more of you being someone that follows principles, structures, processes than just delving into writing code. So, if you want to be a software engineer, the first thing I want to tell you is don't let the coding part actually scare you, because for most persons they sort of feel, oh, there's so much code to learn, there's so much languages out there, so I have to probably like learn Python, I have to learn Java, I have to learn C++, C sharp. No, you don't have to learn all of those. All you need is the foundational thing or the foundational knowledge, and it's easy for you to actually move across board. So I'll give you an instance. I for example, I'm more of a PHP guy. I don't know if anyone knows PHP here. I'm more of a PHP guy anyway, and I'm proud to say it. Although there's a lot of people saying, no PHP, or PHP is not a very good programming language. Well, at least it's paying the bills, right? And I as well do JavaScript exceptionally. I do JavaScript exceptionally. And if you give me a Ruby code to probably like look at as a software engineer, I would be able to tell you what's happening in there. If you bring me a C++ code, I'll be able to tell you what's happening in there. If you bring me whatever language it is, I'll be able to tell you what is in there. And that's because I'm an exceptional software engineer. I'm not just a coder. And that is what I really want us to think from the perspective of. So if you're probably like, I think you probably can see what I wrote here. I said just like architecture is not just about drawing beautiful buildings. If you think architecture is just all about drawing fine buildings, then sorry to disappoint. Yeah, so I would like to know just a quick, because I like to engage my audience. What would you like to be? What are you looking forward to becoming? A software engineer or just a coder? Which one are you looking at? What do you want, or which of these two would you want to be? Do you want to be a software engineer or do you want to be a coder? Both nice. Software engineer, cool. I would like to see more feedback. Software engineer, exceptional. That's awesome. An engineer, awesome, good. Just like when a valuable software engineer, I love that, Sandra. I love that. I love that. That makes a lot of sense. So software engineering, basically, I'll just define shortly. I can see some other feedback, Azan Idris, Tamola. That makes a lot of sense. So a software engineer is someone who basically applies engineering design process. Now you can see that keyword there, applies engineering design process. That means there's a process for you to actually implement if you want to be a software engineer, a software developer. And what you do basically is you design. That's your core responsibility as a software engineer. You design, you develop, you test, you maintain, and you evaluate a computer software. So if you are a software engineer and you just limit yourself to just maybe like design, you've not completed your work. Or probably like you just limit yourself to the development part, which is more of the coding part, then you've not completed your work. Or you probably limit yourself to just like testing, you don't go further. That means you've not done your work. You need to be able to do all of this. You have to write maintainable codes that is easy for every other person to be able to use. You need to be able to write a code that you've properly assessed and you know that this is well optimized. I will tell you some of this. Like I'll still break down most of all of these things I'm saying here. Now, how do computers work? How do computers work? And that is the foundation of software engineering. Now, you cannot be a software engineer without there being a computer. Now, I don't know if anyone understands this green stuff that is here, this 01 thing. Does anyone know what it is? I probably will allow us to be able to unmute at this point. Just a few seconds. I probably allow us to be able to. I'm trying to see if there's a permission for me to allow us on mute, and I would like to hear. Yeah, you can unmute, and I would like to hear one. Okay, binary code, awesome. And I need to understand what binary code itself is. I need someone to actually tell me. It could be Asani Idris, it could be Uchenna. I need to understand what a binary code itself is. What is it doing? Why are we saying zeros and one? You can unmute yourself if you want to talk.
Yeah,
Asan,
good afternoon.
Good afternoon.
Binary code is just the language in which the computer itself understand. That is, even if you're saying anything, so it's have to translate it into its language before it's able to come.
Exactly. Perfect. You're absolutely correct. And that is one thing. Now, for us as human beings, we're interacting in English, whatever language. But right now in this session, we're communicating in English. Yeah, Damola said the only language computers understand, and that is it. Now, for you to be a software engineer, you actually need to know one thing, that computers only understand zeros and ones, right? It's just like your switch on a computer. I'm sorry, in your house, the switch that actually turns on your bulb, right, on and off. That is basically what computers understand. However, computers have or languages have evolved over time, because would it make sense for me as a software engineer to be writing zeros and one all of the time because I want computer to be able to probably like do one thing or the other? No, right? What makes a difference now is we've now been able to have what we call programming languages. And you can see here, you can see me actually, you can see like this chart that talks about like level of abstraction, how computers have over time, we've been able to build on top of computers layers that now helps us communicate with computers, you understand? So now we have what we call probably like zeros and one, which is just what we call the machine language. That's the language the computer understand, right? Now we've been able to now move to what we call the assembly language, right? Something like Fortran. Probably those that schooled in 1980s or 18 somethings, they probably like wrote in Fortran. I studied information and media technology, so I wrote a bit of code, but not Fortran anyway. God helped me. I scaled through. Now we now have more structured languages like C++, PHP. Someone mentioned they do Elixir and the likes. Now, for the computer to be able to understand what you're writing, now there's what we call probably like an interpreter or a compiler that now converts whatever you write that is English-like, it converts it into zeros and one, and the computer is able to understand. Now, when you as a software engineer write your code, you still do one extra thing, which is more like the user interface. Now, the user interface is another level of abstraction, which a normal user, because that's the final level of abstraction when it comes to computers. So you abstracted the zeros and one. That's like you try to hide the zeros and one with programming languages. Now you're trying to hide your programming language, like your code, with an interface that is beautiful and a final user is able to use. So the final level of abstraction in that sense is who? The user, because they don't understand the zeros and ones, they don't understand your code, but they understand the app that you're using. Is that clear? Is that understood, especially for those that don't have an idea as to what exactly is happening here? I would like to see your feedback in the comments, please. Oh, cool. That means I'm communicating. I hope I'm a very good teacher today. So now you can see some levels here. Now, the reason I'm intentionally taking us through this foundation itself is, even if you probably like come to say, oh, you're joining transition school and you're probably like trying to learn software engineering, you must understand these fundamentals. You cannot be an exceptional software engineer without understanding this fundamental. Even if you learn JavaScript till tomorrow, if you learn HTML, CSS, if you don't understand the computer you are working with, it's just like a man and a woman that are in a relationship and they are not speaking the same language. Then you're basically just going to be in a relationship that is full of troubles, right? So here we can see level 6 is the user and is using an executable program. That is maybe like the WhatsApp or probably like the Instagram or the Facebook or whatever application. Then we have high level language, right? Which is like C++, Java, Python, and the likes. Then we now have level 4 assembly language, assembly code. The system software is writing in operation system. The machine itself is instruction set architecture. Then that is also abstracting like the microcode. And your computer itself is an electronic device in itself. So basically, microcode is hiding the circuit, the logic gate, all of those chips that are in your computer, or your laptop. Then instruction set architecture is hiding the microcode. So whosoever is writing operating system does not need to worry about my circuit gates. Whosoever is writing assembly code does not need to worry about the operating system. Whosoever is not in terms of like operating system, in terms of the code for the operating system. Whosoever is working with, let's say, C++, Java does not need to bother about the instruction set architecture. I just go there and write my code. Whosoever is doing the executable programs does not need to worry about this. So that's basically it. I don't want to spend too much time in that. Now, there are different forms of software engineers. There's front-end software engineer, there's a back-end software engineer, there's a full stack. I am a full stack anyway, because I need to make money from both sides. There are software engineers that are probably like focused on testing. If you remember the policy of the definition of software engineering, it is more about testing is one of those things in itself. So we have those in tests, and there are those that actually are engineers in test, and there are developers in test. There's DevOps engineer, some of us might have heard that, security engineer, data engineer, cloud architect, and the likes. Now, let's move on to now a deeper part of coding. Now, this time we're not talking about coding, but I will be bringing it from the software engineering part of things, right? Now, if you want to be a software engineer, right, you must understand this fundamental. These 4 things, they are very important. No matter the code you are writing. Even though if you come probably like to learn proper in transition school, we'll be making use of JavaScript more, right? But the foundation is not again about the language. It's about the principles, the basics of software engineering. Now, some of us probably have heard of variable, loops, conditional statement, functions. So I need 4 volunteers. I need someone to probably like tell me what variables are. I need someone else to tell me what a conditional statement is. I need someone to tell me what a loop is, and I need someone to tell me what a function is. I'm looking, I don't want to mention random names. So anyone that you want to talk about, just type the name in the chat and I'll allow you unmute yourself. Just type the one you want to talk about. If you know what it is, you can even give it a shot, even if you had zero knowledge, right? I don't mind. I'd like to see you in the chat. I don't want to assume we don't know what this is. Can we hear me though? I need to see in the chat. Can we hear me? Am I still here? Am I still audible? Okay. All right. Okay. So Favor would probably try. So Favor, I'm giving you the permission to, you can try and unmute, just a few seconds. You can unmute yourself now, Favor. And Hassan Idris will follow after. Favor, which ones can you try?
Okay, good afternoon.
Good afternoon.
Okay, let me just try data types, loops, conditionals. I can just try on them. So data types, let me just say, like in maths, we have integers, is a data type, like according to Python. Then we have strings.
Yes.
We have strings. We have floats. Floats are like decimal numbers.
Good.
Strings, they are enclosed in quotation marks.
Mm-hmm.
And variable is like let me just say, if you're saying list now is equal to this, the variable there is the list that you're assigning the values inside the set to. Then
great.
Then loops, we have the for loop and while loop in Python.
Mm-hmm. Mm-hmm.
So the for loop continues your the code until it stops at, maybe, let me just say, if you're starting a for loop now, something like from 1 to 5, it ends at when it stops, like the 5, it ends there. That's what for loop does. But I can't really remember the while loop so well. Then conditionals, they're like the if statements, else statements, elif statements.
Mm-hmm.
Like conditional, let me just say you're saying let me just say somebody's age now is 18. You will not be like, if the age is greater than 19 or something like that, then print this, else do that. That's what the conditional is trying to say. Then functions is something like input and output, just like in maths, when you give in something, giving you, let me just say, you giving a function, now you expect it to have an output. So it is in code that you give it, you put in your functions and you expect an output.
That makes sense. Thank you very much. I might not be able to call any other person because Favor just killed it, and I would love to probably like have someone like Favor in class. Anyway, so data types, we have different types of data types. Product design. Okay, sorry, Chiamaka, there's a breakout room for product design, so you can probably like check in the Zoom app. You'll be able to join the breakout session. My colleagues will be able to help you on that. So, for example, we have numbers. So one of the things about software engineering itself is it helps you be able to like put different components in different things, right? So, for example, when you're probably like writing, if you want to be a software engineer, you must understand numbers. There are different types of numbers. There's like this is a negative integer. Integer itself is like number. So this is negative, just like in normal maths, right? So this is negative. So this is a normal integer 0. We can see this is like a float in itself, but this is actually more of what's it called? This is more like a double, but it floats in itself. So float itself is anything in decimal, right? We can see another positive integer here, which is basically without a minus. It is not 0, so it is on the positive side of things. So that's number. We have strings, so anything that is in quotes. So there's single quotes, there's double quotes. Anything you see in your code that has quotes like this itself is a string. So just like how do I put it? If I don't know the number of persons that probably, I think all of us probably like had childhood experiences with having to probably like hold a rope and put in something inside, right? So you're probably like rolling that particular rope, more like that string, and there's something in between. So this is more like the rope that is holding the text in itself. So a string can have a number within it. It can have a text, a normal character, A, B, C to Z. It can have special characters and all of those things. But as long as it is in quotes, it is a string. We have booleans which can be true or false. If it is either true or it is false, just like 0 and 1, then it is a boolean. So these are simple things that you probably were able to remember. Then we have what we call variable declaration. So now, if, for example, I come to you and I tell you, if you ask me what is my name, right? And I tell you my name is Yomi, you have studied somewhere in your head, right? And that is what's more like what variable declaration itself is. Variable declaration is basically a container that tries to hold a value. So it can hold a string, like I showed you, it can hold a Boolean, it can hold a number, right? So a variable itself is like the word variable, it changes, right? There's another version of it that is like a constant. If you remember in maths, you have constant, which does not change, then you have variable that changes. So that means a variable can change. So if I tell you my name is Yomi and I come tomorrow and I tell you my name is no longer Yomi, my name is now probably like Zoe, right? Then you register it in your head that Yomi has changed his name and is now Zoe. And that is basically what variable declaration itself is. Now, conditional statements, I would a bit slow down here so that we can quite understand. Now, conditional statements basically, just like Favor said, conditional statements act based on provided values or provided conditions. So for example, if I have a beard, in natural senses, people would say, I'm a guy. If I don't have a beard, right? Well, there are men that are without beards anyway. So let me look for another example. If I have a broader chest, right? That means I'm a guy. If I have a protruded chest, sort of, right? I am a female, right? And that is more like a condition. If I am black, or sorry, if I look dark, I'm most likely a black person. If I look maybe like lighter, I'm most likely maybe like Caucasian or I'm Asian or anything. So it is based on predefined value. So let me give you an example. So you can see here, we have defined what's here. Someone that probably has not talked before, X is what's here. I talked about something earlier that once you assign something here, like it can hold a value. So something is holding a value of 5 here. What is this X called? I need someone to give me a quick feedback. Someone that probably has no idea before now, but I think by virtue of what I have said, miraculously now understands. I want to be sure I'm a good teacher. So I need someone to give a feedback here. Don't be shy, please. Just feel free, raise your hand, or probably like unmute yourself. Variable, good. Favor, thank you. Variable, thank you. Hassan Idris, thank you very much. So X here is a variable. It can change. That's the first thing, right? Now, here I'm now saying if in coding or any language, most definitely, they would use if as a condition to check a particular statement. So I'm writing a statement here that is X. This is a less than value, just like in our normal maths. It is pretty much the same in almost all languages. If X is less than 5, right? Then I said print out that X is less than 5. Now, if that is not true, then we have an alternative condition, which is else. It should tell us that X is greater than or equal to 5. Now, what value do you think this would give us? What value do you think this will give us? This will most likely give us what value? Now, what will it print out here, basically? I need a feedback. You're holding me back. I'm waiting for a feedback. I want to assume we're typing. If you probably like want to probably like speak, you can speak.
X is less than 5.
Good. Will it? Check it very well. X equals to 5. If X is less than 5. You tried, but are you sure? Let's argue this out. Because is X really less than 5?
X is greater than or equal to 5.
Exactly, because this condition, so basically what it does is it checks if this condition equals to true, right? If you remember, we have Boolean. So this, if anytime you use if, it is always trying to equate this to a Boolean. So if it is now true, right, it will return this first guy. If it is false, it is returning this other guy. So coding is always all about the zeros and one. Don't always forget. So anytime you're checking condition, it checks for is either a true or a false. Now, the second thing itself is loop. Now, how many of us have ever tried repeating one same thing all the time and we have never gotten tired of it, except for eating anyway? You've always done that particular thing at one, like always the same way, the same, probably like you follow the same road to maybe like I don't know, to wherever you're going, or probably like there's just one thing that you constantly repeat yourself doing, but you hate the fact that you repeat doing it. Now, I wouldn't want to, oh, you have, nice, coding. Well, I love coding anyway, but I hate having to fix bugs. Now, one beautiful thing itself is programming tries to simplify your life. So you can imagine you want to write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And for every single line, you're having to write 1, 2, 3, 4, 5, right? Now, that is a strenuous process because you are trying to repeat yourself. And there's one principle in coding, which is don't repeat yourself. Never repeat yourself. So anything that makes you repeat yourself, you have to optimize your code. You have to rewrite your code. You have to review it again. And that is why we have what we call loop, to repeat things over and over again without having to write it all over. So you can see here we're doing repeat, print 1, print 2, print 3, print 4, print 5. Then before we say here's the end. But here we are saying for I. So for I in 1, 2, 3, 4, 5 itself. So that means I will do 1, it will go here, 2, it will go here, 3, it will go here, 4, it will go here, 5. Then it will carry out this function for each one of them. So it will be printing all of this based on this for loop that you have provided, right? Instead of you having to be writing it manually, and that's what a loop is. Then you can see here, it actually returned these values by itself. Now, let's move on to the next thing, which is, so I wouldn't be able to go so deep into that because of time constraints. Now, the next thing itself is function. So function itself basically executes something. We perform certain functions every single day in our life. One of the things I love the most itself is eat. Eat is a function. Anything that makes my mouth do yum, 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 yum is what I love doing anyway. I love eating anyway. So if that is the case for me, there is a function for eating. So you can also write a function in your code to ensure that something is done, something is performed. Like your calculator now, you can see here, we did add A, comma B, right? That's a function that now always returns A plus B. So you can imagine if, for example, I want to do 1 plus 2, 3 plus 5, 6 plus 7, right? And I'm having to just say A plus, like 1, I'm having to do that all the time. I'm repeating myself too much. So to ease that stress, we write what? A function. You can imagine for every food that you're having to eat, you have different mouths that is generated all the time that you're having to eat. Your body will definitely be overflowing with mouths, right? But to reduce that stress, God has so much amazingly created a mouth, one single mouth that performs that one function for eating. Well, it probably does other things aside eating, but majorly it eats. So that is you defining function. And you can see here, I defined a function greet. And anytime I call the function, anytime I write it like this, I'm calling a function that greets people. You understand? So that's basically it. Now, if you're not getting some of these concepts, you can, this session is obviously recorded, so you can rewatch at any time. So that is more on it around data types, right? And also major fundamentals of coding. Now let's move into the next part, which is like another fundamental of coding, which is what we call data structure. Don't be confused by that word, data structure. I will simplify it. Data structure, let's break out that word. Data and structure. The structure of your data. What is the data here? The data here is probably like your string or your number or your Boolean or your number, anything that you most likely will probably like assign to maybe like a variable or a constant. Now, how that data is structured in itself, because software engineering is mostly you working with data, right? So how can you render your data, or how can you use your data in a structured format? Don't forget, software engineering is a field of principles. If there's no principle, there's no software engineering. So now we have what we call list. Don't cram all of this. I will simplify. We have what we call list. We have what we call dictionary. We have tuples, queues, binary, graph, hash table, linked lists, and yada, 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 that I don't want to confuse you. Don't worry, you get most of these things, right? But is there anyone here that's any of these things that you've never seen anywhere before? I would like to see in the comments. Is there any of all of this that you've probably like been writing code, or you've probably never written code, but you've never seen any of this before? I'd like to see your feedback on that. Any? Is there anything here? Oh, hash table binary tree is good. So I'll just clarify a few of these things. So list itself is also called an array in some other languages, right? So a list itself is, you can imagine you going to the store, or probably like you want to go to maybe like a restaurant, you have a list in your head as to the things that you want to buy, right? So in programming or in software engineering, we have what we call a list or an array. So if you don't call it a list, you can call it an array. So it basically holds the value of different types of data, right? That you want to probably like assign to a variable. So for example, we have a variable fruit here, and it has a list of mango, banana, strawberry. Now, if it is just random that is here, it could be probably like 1 banana, 4, 17, 4.0. Basically, when you're going to the market, right, you are not just going to the market to buy just maybe like food items alone. You might want to buy drinks, or you might want to buy maybe like a gift for maybe like your partner or something. So it doesn't have to be the same type of data, right? And that's the beautiful thing about lists, right? You can have different types of data for maybe like your list. You have what we call tuple also. Tuple itself is, so okay, now tuple itself is a bit more like list, but the difference itself is in tuple, you cannot have repeated values, right? But in list, you can have repeated values. So you can have mango here, then you can have another mango here. So maybe like you forgot to write mango before, you can still write mango again. You understand? So like you're going to the store and probably like maybe your sister, your fiance, your spouse now calls you and like, oh, I forgot to mention that you can buy another extra mango or another extra banana or another extra strawberry, right? But tuple, once it is already in the list, it is already in the list. It can't change, right? So you can't have multiple of the same value. Now, we also have what we call dictionary. So dictionary itself is, let's picture a normal dictionary. In some languages, we call it object. So look at your normal dictionary. By the time let's say you want to look for the definition of, let's say, someone should give me any random word I want to check in the dictionary. Any random word. I'd like to see, I'm waiting for a feedback on that. I like my class sort of engaging. As much as I would love today to be so engaging, right? I'm quite fast because I have a time constraint as well. Fiction, good. So when you're looking for the definition of fiction in the dictionary, how do you search for fiction in the dictionary? You go to F, right? Then under F, you now try to scan through one by one to look for where fiction itself is. Then you're able to see the definition. So in this case, you can see person, right? You're looking for a person with a name, right? And what is now the value of that name? Keith, right? So basically, dictionary itself is what we call a key and value pair. Fiction is the key, right? Then the value is the definition. So you can have multiple, you can have, just like in your dictionary, you have multiple words. So multiple keywords or keys, you understand? Now, for every of those keys, they must have a value. So that is why we have dictionary. The reason we have dictionary, which is also called object in some other languages, is so that we can have keys and their respective values. You understand? So for every, let's use normal key holder, for example, the key to your house. For every key, there's a lock that it can open, right? So there's a reference point for every single key, which is the value. And you can see the difference itself is we're using a curly brace for dictionary. We're using a bracket for tuple, and we're using a square bracket for lists or array. So the other types itself is stack, queue, graph or node. We have tree, right? So for stack, so let me just explain what a stack is. I'm sure a number of us have held stack of money, and you can see here. So if someone comes and places another bundle of cash on top of the existing stack of money, and someone comes to you and tells you that give me XYZ, the chances of you picking money from the top of that list is higher than you having to go in between to go and pick some random money, right? So just as you can see here in this picture, a stack itself is what we call LIFO, last in, first out. The last item that come on top is most likely going to leave first, right? In beginner software engineering, you might not have to stress about this, but as you go more advanced, you actually will be stressing a lot about this, guys. Now, the second type of data type in this regard is queue. So queue and stack, they are more like words and opposite. So queue itself is, I don't know the last time you probably like queued to probably like buy something at a store or probably like maybe you want to enter into a bus or something, right? In a queue, it's the first person that comes. Let's say it's a banking environment. If someone tries to come from the back and tries to maybe like shunt at the front, it's going to be a problem, right? It's going to be a catastrophe. So in that same sense, a queue itself is first person that comes in is the first that goes out. So if you're creating like a list of data, probably like, and it is meant to be a queue, the first guy that comes in is meant to be the first that goes out. And there are situations where we use all of these guys. We have graphs, we have tree. I wouldn't want to probably like talk so much about this so I don't confuse, especially those of us that are probably like just getting started, right? So if you're getting started as a software engineer, before I move forward, I hope that part is clear, and I hope there's no much question before I move forward. I would like to know if you have maybe like, if you can raise your hand if there's a question or you need clarity, so I can just clarify on that, please. The section where I talked about data structures. Oh, can you say queue is like FIFO? Yes, queue is FIFO, right? Queue is first in, first out. If you join any queue and it's not the first person coming out first, maybe like the last person is going out first, then that is a LIFO, last in, first out, right? Last in, first out. So let me give you an example of situation where you use queue. Queue is probably like, let's say on a website, people order items, right? And you probably like, maybe like the last person that probably like clicked, let's say, I'm trying to get a very good example here so that it's clear. Someone comes to an e-commerce website, right? And they are to dispatch their item, right? I ordered on the same platform of with the same probably like with the same on the same platform. What will you call a situation where the middle will be the first out? That's an awkward situation. That's an awkward situation, and that will probably be maybe you intentionally want to bring in from the middle, but that is a situation that should probably like never arise. If that is going to be arising, probably like you're making use of a typical array, and that's an exceptional situation. There's nothing like middle in first, middle in last, or something. Nah, we don't have anything like that. Probably in such scenario, you probably have to use maybe like a graph, because that's point you can pick from any node, any point in itself. So the example I was trying to give is if I order something on an e-commerce website, right, and it's to go to dispatch. Now, if I'm coming first and I'm placing my order first, I'm expecting that my order is first received on the dispatch before the next person that is behind me, right? Or probably another person coming from another place getting on the website is now placing order. So if I'm placing order first, I'm expecting my order to be delivered first. The same thing happens for as many scenarios that we can think of, you understand, which is definitely different from a LIFO. So let me just move on. So if you're writing your first line of code, what do you need? The first thing obviously is your computer. Obviously, you cannot write a code without computer. Anyway, my first line of code that I wrote was on paper, but I couldn't run it because I had no computer until I was able to afford a computer. So the first thing you need is a computer. Then the second itself is the choice of programming language. Now, there's one thing I tell people would have questions. Now, that should I learn JavaScript first, or PHP first, or Java first, and the likes? I would tell you, learn any language you feel pleased to learn first. But focus first on that language. Learn the fundamentals of software engineering. Don't just move everywhere, right? When you're now established, you can now start exploring other languages. Again, for some transition school and for the purpose of what we are trying to build, we use JavaScript mostly because it's actually, with JavaScript, you can move across different industries for mobile development, for web development, for even desktop for desktop development and the likes. So that's why we use JavaScript. Then the second thing the third thing you need itself is your IDE. So IDE itself is basically your integrated development environment, more like the software you use to run your code on your laptop. Now, the easiest way to learn, if you want to be a software engineer itself, is not just watching tutorials. Now, that is not the best or easiest way to learn. The easiest way to learn is have a project in mind that you want to build. Have a product that you want to build in mind. Then based on that, now you start watching tutorials. After you've picked the language you want to use, now you can now start watching tutorials that help you execute each task in that particular project you want to build. So obviously, if let's say I want to learn, maybe like I want to learn Python, for example, what I'll put in mind is what can I build with Python, right? So I can Google or probably like use ChatGPT, like projects, simple project for a beginner for in Python. Then based on that, I pick one random project and I'll say, okay, now this project, for me to build this project, what are the tasks that are required? I structure all of those tasks, and that is you basically being a software engineer. You structure, you architect basically those tasks in itself. Then for every single task that you are to do, you can now watch a video tutorial on how to execute. That is the best way to learn, not you just watching video tutorials for watching sake, right? So have a project in mind. That's the best way to learn. Now, these are different languages here. I would have asked us to mention which language this is, but I already put their name. So that's a fail from my end. So there are different languages you can learn, but for us here in Transition School, we focus more on JavaScript. There's C#, there's C, there's C++, there's Java, there's PHP, there's SQL, there's assembly language. I'm not sure any one of us here wants to start with an assembly language. And these are some IDEs. That's like softwares you can run on your computer to probably like use to run your code. I use VS Code, which is this guy, Visual Studio Code. But we have a couple of like other other IDEs that you can use. I also use PHP Storm, this PS. I also use PHP Storm. You don't need to install all of this. One is enough. The reason I use PHP Storm is basically because my workplace requires us to use PHP Storm. For my personal project, I use VS Code. Also, if you're probably like a PHP person, PHP Storm is best for you. But if you're not probably like focused on PHP, you can use any other language. I'm not, however, using PHP for this. So basically, I'm almost going to wrap up with this, right? Everyone should learn a code, and that's Steve Jobs. Everyone should learn a code, whether you are a beginner, whether you are in between, whether you are an entrepreneur. It is best to learn a code because the future itself is going to be even more code dependent. You can see people having to do, what's it called nowadays? People are having to do what we call SaaS, SaaS, software as a service and the likes. So there's an ID that comes with Python. Is that one okay? Very well. So I don't know if you have any question, and I think that's just going to be it. If you want to learn more about software engineering and the likes, you can join our course, and that will be awesome. Someone said Atom has been archived. There will be no updates. It is one decided. There'll be no updates. It is one decided to use it, right? I'm not sure I got that question. But I don't use Atom, so I didn't even know that it's been archived anyway. But there are tons of tools you can use out there. So I don't know if you have any question, you can drop them in the chat, because this is the end of today's session. I hope it was helpful. I hope it was able to help us understand the basics of coding. I wish I could write some codes here, but it's not something the time would permit in itself. But anything you want to learn, I think this has been able to provide a foundation for you to be an exceptional software engineer, because there's no exceptional software engineer without understanding, that doesn't understand the basics. The basics is the foundation on which you are now able to build on. So you can go and learn the code. You can join our next cohort. You can reach out to me on social media and every other thing if you have questions and all of those things. Yeah, what has been explained so far, is it for front end or for back end? For both, actually. You can't even write front end without understanding this. If you're now to be focused on front end, you'll be learning HTML, CSS, JavaScript. But in JavaScript, you need all of this. You cannot be an exceptional front end engineer without understanding these basics. So it's actually for both. But if you want to get started, I would recommend that you start with front end. Then you can now move from there to back end, because it is more easier for you to understand. That is if you're focused on web. If you're not looking at web, you could even start with web, but eventually start moving on to that. Most times looking at tutorials and real-time projects, it seems there's a vast difference. Why? The reason itself is you're actually trying to build something real. For a tutorial, it's just something to understand how something works. But for a project, it is more detailed. You don't have to build something deep in that sense. You can build something simple, a simple calculator, a simple quizzing system. It's just something simple. There's what we call MVP. So you don't have to build the entire features. Just build something simple. Then you start building on top of it with your tutorials. So there definitely there'll be real gap in terms of the learning process. You understand? but you just be intentional about building in bits, and from there you get it. I don't know if there's any other question. I'll be more than happy to answer. And for those of us that probably will be signing up for either of maybe the back end or the front end, I would recommend the front end anyway for anyone that is probably like joining us. Then would get to see in class. For someone that wants to learn back end, it's more focused on how you can build APIs and the likes. I think how the classes are scheduled, it will be answered by Praise once she joins, once she comes back here. But basically, I'll just try and explain in brief. Classes are on Saturdays, 3 hours on Saturdays. Then during the week, you and your colleagues, you'll be meeting to build your project. You'll be assigned a student's project manager who will also be working with you. Also, you'll be working with product designers, especially if you're on the front end side. If you're on the back end side, you really won't be working with UI UX designers. You'll be working more within your team and your project manager. So that's basically how classes are scheduled one time within the week and Saturdays in itself. For someone, so Suleiman is asking, when is it going to be best time to learn real experience like an intern or a job? For us, what we try to do itself is once you join or once you sign up, right, you're actually working on like a realistic project within transition schooling itself. And that's actually within the parents company. We have a number of projects that we have. So you just be assigned to one of those projects and you'll be learning while building that particular project in itself. So you can make reference to it that, oh, we worked on this. So it's more like you're interning, but you're actually learning in itself. Yeah, so I think that's probably like it. Once you're done with our program, you can probably like choose to still intern with us, or you can choose to intern with us. You can probably like look for internship out there. But one thing that will place you on high value itself is if you work on real stuff, companies will come for you. But if you don't work on real stuff, you most likely will not be able to see companies come for you. I won't recommend that you do back end and front end at the same time. I would recommend focus on front end, then gradually move to back end. Don't learn both at the time because it will be quite a lot of information at the same time. Will the classes be recorded if one misses out? Yes, classes are recorded because we understand that people have different schedules, right? So classes are recorded. However, we recommend that you are in sessions, especially even with your colleagues, so that you can really have and take advantage. It won't make sense that you pay so much money and you're gaining lesser value. So we would recommend, but classes are recorded. If you have assignments, ensure that you meet up before the next class so that myself or whoever is a facilitator is able to provide sufficient feedback and all of those things. I don't know if there's any other question. So I think that's pretty much it from my end. Yeah. Oh, nice, Sandra. You can probably like drop a message in the WhatsApp group. I think the WhatsApp group was shared earlier, and Praise would definitely be reaching out to you on you officially signing up. So I think that's pretty much it. I don't know if you have any other question. You can drop a message. You can probably like unmute or something, and I'll be more than happy to respond. Okay, I think guys are coming back now. I'm trying to see if they are. Okay, they're almost done. I think product design guys are as well enjoying their session. So yeah. If you have any question, please feel free to ask. It can be still on software engineering or something outside of software engineering. I'll be more than happy to assist.